So let's try one of these out. Let's say it's about time to eat and we want to compare two national pizza chains because we want to see which one has more saturated fat in their pizzas. So here are the saturated fat content in grams for several pizzas sold by two national chains. Let's call that brand D or Diamondos and brand PJ for Papa Juan's. What I want to know is one of these pizza chains, do they have more saturated fat in their pizzas in comparison to the others? So let's look at the data. For our null hypothesis, we're checking to see if there is no difference in the mean saturated fat content. Our alternative hypothesis is that there is a difference in the mean saturated fat content. Before we jump to the technology, let's check our assumptions and conditions. Number one, independent group assumption. The two samples of saturated fat contents were chosen independently of one another. Next, the randomization condition. There's no mention of randomization, so we'll assume that these pizzas are representative of all of the pizzas by these two chains. The nearly normal condition, which we can check from a histogram, both distributions of saturated fat content are roughly unimodal and symmetric. Since the conditions have been met, we can do a two-sample t-test for the difference of means with 32.757 degrees of freedom. I'll show you how we get that in just a second. So let's jump over to our calculator, where you can see that I have made a spreadsheet. And if you forgot, you can always you can hit Control, Document, and then you can just go add a list in spreadsheet. I'm not going to do that for us for right now. So I'm going to go to my spreadsheet. I have labeled column A D for Diamondos, and I labeled column B for Papa Juan's. And you can see I have all 20 of the data points entered in for Diamondos, and I have all 15 of the data points entered in for Papa Juan's. Now what I want to do is I want to make a histogram to compare these two. So again, if you hit Control and then Document, you get a new document. What we want to do is add data and statistics. And what we want to do is select on the x-axis at least one of our variables. And as you can see, it's a dot plot. So if we hit Menu and we go to Plot Type, we can make that a histogram. What you can also do is go to Menu, Plot Properties, and add an x variable. And what we want to do is also add in the Papa Juan's. So as you can see, I have Domino's on the top in green, and I have Papa John's, or Papa Juan's I should say, in green. Now, if you would like, you hit Menu, Plot Type, and as we said in the notes, we can compare these as box plots. As we look through these, we can see generally from our 5-number summary what our max and mins are for our range, where our medium is, where our spreads are. So we can kind of see that in comparing these two means that it looks like Domino's is a little ahead. So if I go Control Menu and I add a calculator, what I would like to do is to do a two-sample t-test. So how do we do that? We're going to hit Menu, and then we're going to go to Statistics, and then we're going to go to Stats Tests, and then we're going to go to two-sample t-test. And in this case, I want to use the data. So in list 1, we're going to say that's Domino's. In list 2, we're going to say that's Papa John's. Frequency list 1 and 1, our null hypothesis was that they are not equal to it, so we're doing a two-tailed test, and we're not pooling, so we hit OK. And from here, we should see some interesting numbers. We have a p-value of 0.000003 with a degrees of freedom, which you don't have to calculate, of 32.757, our averages, which it automatically calculates for us, and our standard deviations. So this is why it's important to jump to our calculator before we do the handmade calculations. So what we need to do by hand is to calculate the t-score. So we take our averages, subtract our means divided by our standard error. So that would be 11.25 saturated fat minus 6.53 saturated fat minus our null hypothesis is there's no difference divided by the standard deviation squared over 20 plus the standard deviation squared over 15, which gives us a t-score of 4.823, just like what the calculator said. What we're comparing this to is a normal distribution, and we're doing a two-tailed test, so we are going to multiply our probability by 2, and we're seeing what's the probability we get a T with degrees of freedom of 32.8 that's greater than 4.823, which gives us a p-value of 0.000003. Remember, we're comparing the t-score against the critical t-value for this number of degrees of freedom. So our t-value, our critical value of 32.756 degrees of freedom is as follows, which would lead us to a conclusion of, since the p-value is very low, we reject the null hypothesis. There is strong evidence to suggest that the two pizza brands have different mean saturated fat content. Domino's appears to have more saturated fat on average than Papa John's. And let's actually dial that in with a confidence interval. So now that we see that there's a difference in the p-value, that there is some statistical evidence that says that Domino's may have more saturated fat than Papa John's, how would we tell exactly or give us a confidence interval? So this is where, again, we're going to go straight to our testing. And this time we're going to go menu, statistics, confidence interval, and we have a 2-sample t interval. And again, because we have data that we typed in and spent a little time on, we're just going to use the data. We're going to use our first list is Domino's. Our second list is Papa John's. Our confidence level that we're testing is 0.95. And again, we are not pooling here, so we hit OK. From our data, we can see that our confidence lower level is 2.72 and our confidence upper level is 6.70. Remember that we're testing the difference in the means. We get our margin of error, which is about 2 grams of saturated fat with our same degrees of freedom, our averages, our standard deviations, and our sample size. So let's put this in context. The conditions have been met, so we can create a 2-sample t interval for the difference in means with a 95% confidence. So we take our difference in our averages, which we're subtracting Papa John's from Domino's saturated fat average, plus or minus our t critical value, which we found earlier, times our standard error. Again, don't find the critical value by hand. We're going to use either the calculator or a chart, and we get our lower bound as 2.73 and our upper bound as 6.71. Therefore, I am 95% confident that the average saturated fat content for Domino's is between 2.73 and 6.71 grams higher than the average saturated fat content for Papa John's. I hope this calculator calculation showing both a confidence interval and a t-test was beneficial. See you later.